Okay, so let's get started. Actually the temperature is not too bad in here with all these computers, but the heat's off for the rest of the engineering building, probably for the week, and also in the natural sciences building. So just so you know, it might get a little chilly depending upon where you're at. Okay, so let's talk about this first exam. It was a little harder than I intended it to be, I guess. So there were only 2 people that got everything right. So I didn't have a lot of comments on them. So if something was wrong, most of them, I just put an X by it. And so what your task is sometime this week to figure out what's wrong with the ones that have an X by it and then resubmit it. And so when you resubmit it, don't just put down the right answer, but if you can explain also why the first answer was wrong, then do the combination. So what was wrong before with what you put down, and then the correct one. And so most of the ones that were turned in, I was a little bit picky, and so there are some of them where the correct thing is a pretty small change. So some of them you could probably just see right away in a minute or two. Others might take a little bit longer. So when you have that done, whenever you've got that finished, then hand them back in to me. So and you can go ahead and run them on a computer or whatever. So you can figure them out using whatever means necessary. So any questions there? Okay. All right, so whenever you can fix those, go ahead and resubmit. It could be today or whenever this week. I'd say probably in the next couple days would be good to get that out of the way. All right, so any questions? All right, so we were talking about loops, and so let's do some more looping examples. So previously we covered the while loop. And so when we did the while loop, we had while something that became a Boolean inside parentheses. And then we put some code in here. And then we said that whatever's inside here would just repeat while whatever this condition was true. And so you can do all your loops if you like using just the regular while loop. There's 2 other kinds of loops that I like to talk about. The next kind is the do while loop. And the place where you would use the do while loop is when you want to always run the body of the loop at least once. So by the body, I mean whatever is inside the curly braces. So with the regular while loop, it's possible we come in here, this condition's false, and then we skip and we don't run what's inside the body at all. So with the do while loop, it looks like this. You have the word do, and then the curly braces. And then the while comes at the end. And so it's pretty similar. Oh, and here's one thing. You actually put a semicolon right here. And so that's a little different than the regular while loop where you don't have a semicolon. So you do put a semicolon on the do while. So with the do while, we would come in here and we would always execute whatever is inside the curly braces at least one time. And then when we get to the bottom, we check if this thing is true, then we go back and do it again. And then we'll do it again. If this is still true, it goes back. And so it just keeps on doing this over and over again until this thing becomes false. And then when this is false, then it just continues on with whatever comes afterwards. So we could turn the do while into a regular while, and so it would look like this. Let's just say I have whatever code in here. The equivalent of the do while would be the following. You would have the code executing first, then you would have the while loop. Whoops, yikes. I keep hitting my trackpad here. So this would be the equivalent if you took a do while loop and you turned it into a while loop. And so, well, with the do while loop, you always run the code at least once. And so with the while loop, you might not. And so the equivalent is you take this code out and you stick it here in front of the while loop. So you make sure you run this code. Then you check if this is true or not. If it's true, then you go and run the code again. If it's false, then you would just skip out and do whatever comes afterwards. So these would be equivalent to each other. If you wanted to go the other way, if you have a while loop, so if you have the while loop like this and you wanted to turn it into a do while loop, then you'd have to do the following. You'd have to make an if statement, and so if it'll look something like this. So with the regular while, there's a chance you don't run the code at all. So if you come in here and this thing's false, then you just skip out. And so to do the equivalent with the do while, you have to wrap it around an if statement. And so you check, oh, if that thing's false, then it would just skip down here. But if it's true, then it would run the body at least once and then check. And so then that would make the equivalent where this would run the body at least once and then check. So you can go back and forth between the two. So the place where you'd want to use the do while is basically if you know you want to run this code at least one time, then use the do while. If you may or may not want to run the code one time, then use the regular while. But anyways, this shows that you can go back and forth where you don't really have to use the do while. You could use an if statement instead with the regular while. So kind of take your pick. Let's see. So here I'll just show one example. And I'll just go do it actually in the program. Oops. And so one typical place you would use a do while would be where you want the user to select from a menu. Let me go get rid of all this stuff. So a typical thing would be you want the user to pick from a menu, and here's like a common thing you might do: system.out.println, enter choice 1 or 2. So let's say you'd like the user to pick 1 or 2, and to do this I'll go and make a scanner. And in this case we're inputting a letter or a digit, so I'll make an integer. And so normally you just say this choice equals keyboard.next line or next int. And then you do whatever you want to do with the choice. I'll just print it out. Okay, so here's what we would do right now. And so I compile this and run it. So we enter, say 1, and it says you chose 1. But right now there's nothing to prevent the person from entering 3 to be sneaky or whatever. And then it just continues on and lets them choose 3. So maybe you don't want that to happen. Maybe if the person picks something that's not 1 or 2, then it repeats. And in this case, if I pick something that's like a letter, it's going to mess up. But so for now, we won't worry about that. But so let's assume that the person picks a number, but we'd like the person not to be able to pick 0 or 3 or something. So we want them to pick 1 or 2. And what we could do is make it so the loop repeats if the user picks something else. And so we could use a do-while loop for that, because we know we want to ask the person at least once to type something in, and then repeat if they type something that's different than 1 or 2. So we could put this inside a do-while loop. So I put a do right there, and then I'll put the right curly brace here. And we like to keep doing that while their choice is not equal to 1 and it's not equal to 2. And then I have to put parentheses around the whole thing, and then a semicolon. And so this says if they type something that's 1 or 2, then it should repeat. So if we think about this, what if the person types in 0? Then 0 not equal to 1 would be true, and 0 not equal to 2 would be true. So these would both be true. So when you have true and with true, you get true. So then we'll come back and do this again. But if the person types in 1, then 1 not equal to true would be false. 1 not equal to 2 would be true, but when you and a true and a false, you get false. So then that would make this loop stop and then go on and say you chose whatever. And then the person typed 2, 2 not equal to 1 would be true, but then 2 not equal to 2 would be false. And so when you have a false and with a true, you get false, and that would make it stop. So if you enter 1 or 2, it's going to make this thing false and stop. Any other thing would be true, and it would make it repeat. So if we run this, then now if we type in like 0, it makes us do it again, or 3 or 4 or 5 or 6 or 888. It's going to crash if I type in a letter, but we'll figure out how to deal with that later. But if I type in 1, then it stops. So there's like an input validation loop where it makes us go over and over again if we type something that's not 1 and not 2. A common mistake would be doing something like this because it sounds like it should work. And so if we change that and to an or, then if we just kind of run through this in our minds and kind of speak it out, it says repeat this thing while the person types in something that's not 1 or not 2. And so it might just sound logical for that to work, but this won't work because whatever we type in, one of these will always be true. So whatever number it is, it's either not going to be 1 or it's not going to be 2. So if I typed in 1, then 1 is not equal to 2, so this side would be true. And if you have a true ORed with anything else, it's true. And then if I typed in 2, then 2 not equal to 1 is true. So then you have true or with false, and that's true. And if I typed a number like 3, then these are both true. So if I use an or there, then this thing will always be true, and it'll never stop. So you have to be a little careful about using ands and ors here. So in this case, I type in 1, 2, 3, 4, 5, whatever. It's going to just go forever unless I make it crash or something by typing in non-digits. So having said that, Be a little careful about your ands and ors because logically in your brain it might sound reasonable, but it might not work when you step through it in terms of how the computer is going to execute it. This is actually like a decent place where you might introduce a Boolean variable. And so we could make a Boolean for repeat. And inside here, I could say something like repeat, or let's not call it, no, I guess I'll leave repeat. I could do something like this. If choice equals 1 or choice equals 2, then repeat equals true, else repeat equals false. And then this thing down here becomes do this while repeat is true. So this, I think, makes it a little more readable. Instead of having to figure out the ands and ors, then if we look at this, we say, oh, if the person types in 1 or 2, then repeat set to true. When it gets down here, it's going to do this again. But if we type something that's not 1 or 2, then repeat set to false, and then this shouldn't repeat. So, whoops, and then, oops, I need to use a Boolean here. So if I type in 3, and oops, I messed up my logic. So I typed in, did I get this backwards? I have my logic backwards. So I type in like 4, let's see. So I have this the wrong way. So if we typed in 1 or 2, then you want to quit. So I should make repeat false. And then anything else, then we should make repeat true. Okay. 3 and 4, 0. All right, one last thing I'll mention about this. Typically, we won't write repeat equals true. I mean, that works fine, but commonly we'll just use repeat right there. Because if repeat is true, then it's going to, then you get while true, and it'll go ahead and do this again. And then if repeat is false, then it'll just exit. And so it's a little redundant to check if it equals true or false, because checking if it equals is the same as whether or not it is true or false. So this would give you the same result. Okay, so any questions about the do while loop? All right, and so the next loop to talk about is the for loop. And usually this is used for counting. But you can use it in other ways if you wanted to, but that would be kind of non-standard, I guess. So here's the syntax of the for loop. You have the word for, and then in parentheses, you have this first expression, a semicolon, the second expression, semicolon, and a third expression. And I'll say what these are in a minute. And then typically you have curly braces and then some code in here. Okay, so what do these 3 things mean? These are all optional. You could leave them off if you want, but you do have to put the semicolons there. So you'd always have at least 2 semicolons inside the curly braces. So we can say what this does in terms of an equivalent for loop. And so here would be the equivalent loop. You would have expression 1 first, and then a while, and then whatever this second thing is, and then code, and then 3. So this would be the equivalent of the for loop and while loop syntax. And so what this is saying is whatever comes here first after the parentheses would be done once before the loop begins. And so this stuff is done once before the loop starts. So this is where you would stick like initialization code that you only want to run once. The second thing over here is the Boolean expression that should be true while the loop continues. So while that thing is true, the for loop is going to keep on looping. And it's just like the while loop. If this thing is false right to begin with, then it doesn't do the code at all. So just like the while loop, if this thing's false, it'll just skip down with whatever comes after. And then this last thing, this expression 3 at the end here, that's code that's run at the end of each loop iteration. And so that's right down here. And so after it runs the code, then it would do this thing down here. So normally this would be something like you add 1 to your counter, or you do whatever it is. So whatever this thing is, usually it does something so that eventually this expression becomes false. And that's usually what this third thing is. Yeah. Each loop iteration. So that means like this loop, it runs the code once, and then it would do this expression 3, then it go back and then run the loop again. So this gets run every time. So you could take a regular while loop and you could map it to the for loop, but normally we'll have this for counting, where you'll set some, here I'll do a typical example like this. So if you wanted a loop that goes 1,000 times, then normally you'd say something like this for, let's say you have some variable I. For I equals 0, I less than 1,000, I plus plus, whatever. So this would be a loop that would run 1,000 times. When it comes in, I would be set to 0 once, and then it's going to keep looping while I is less than 1,000. Well, initially 0 is less than 1,000. So then it'll run whatever I put here, and then when it gets to the bottom, it'll do the I plus plus, so now I becomes 1, and then go back up here. It'll skip this because that only gets done once, and say, well, 1 is still less than 1,000, so it'll do this body again, hit the bottom, add 1 to I, now it becomes 2, 2 is still less than 1,000, and so forth. Eventually I becomes 1,000, at which point 1,000 is not less than 1,000, then it'll skip down here and do whatever comes afterwards. So that's like a typical kind of loop. If you didn't want it to run 1,000 times, but you wanted to run x times, where x is some variable, then you would just stick x here, and whatever value is stored in x, this loop would go that many times. Another little variation on this is to do this. If you declare the variable right here, then this makes a variable I, but it only exists inside this loop. So if the variable is declared here, we'll say more about this probably tomorrow. But the idea is, if you put the variable declaration right here in the loop, then you can only use I inside these curly braces. Once the loop exits, then I is gone. So that means if, like right here, you tried to access I, you can't. So this is called a local variable, so it's local to the loop. And so you see this quite a bit with for loops. And the reason why this is considered a good thing is if you're the person that's writing this little bit of code here, then you have like complete control over this variable. So you know exactly what it's going to be set to and how to use it. But if the variable is, defined somewhere else, like up here, like at the top of your main or something, then it's possible that I could be set to other things, whatever, 100 or something. And so maybe when it comes in here, maybe you don't want it set to 100. It's just a nice way where you can control that variable and no one else can mess with it. Okay. So let's do a couple little examples. So here's like, I'll just write them out here in Dr. Java. So this first example, let's say we just want to enter 10 numbers and compute the sum. Then a typical thing we would do would be make a variable for the sum and set it to 0. And then we could do this. We could make a for loop for, I'll do it this way. So here I made a for loop for this variable I, and since I declared it right here, it only exists inside these curly braces. So while it's less than 10, then do the following. Let's input a number from the keyboard. So we'll just say another one, int entered num. So we read in an integer, and then whatever we type in, we just add it into sum. And then after this loop is over, we can print out the sum. So this should loop 10 times because I start where I is 0. It'll do this thing. When it hits the bottom, add 1 to I. It'll add 1 to I because of the I++ right here. And then check, is I still less than 10? And so it'll be 1, and it is, so that you repeat 10 times. So let's try this one. So here I'll just enter 10 ones, 5, 6, 7, 8, 9, 10, and then it tells me the sum is 10. A common mistake that people make with for loops is people sometimes will do this. So anyone know how many times this would run how many times a loop would run if I put this down here? So in this case, it would only run 5 times because when it gets to this line, it would add 1 to I, but then when it hits this right curly brace, it will run whatever this code is after the semicolon, and then it would add 1 to I again. So this would actually add 2 to I. So this would only go 5 times. So if I enter 1, 2, 3, 4, 5, then it stops because it added 2 to I every loop iteration instead of just 1. So don't forget that this will be done for every loop, every time the loop runs, and so you don't need to add a I equals I plus 1 at the bottom. Another common mistake is putting a semicolon right here at the end. And this will compile, and if I run it, then here it asks me to enter a number. I type 1, and then it prints out 1 and stops. And so what happened here is when there's a semicolon right here, that tells Java that there's no loop body. So it's going to set I to 0. 0 is less than 10, so it's going to run nothing after that because the semicolon says end the loop. And so this means there's nothing to run as far as a loop body. It'll just add 1 to I, and so then I will become 1, and then it'll check again 1's less than 10. So basically go back and forth between these two lines right here. If I put a semicolon right there, where I just gets added 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When it hits 10, then it exits this loop, which means that it goes to the next statement, which is right here. So then it asks me to enter an integer, adds that to sum, and then it prints it out. And so essentially, by putting a semicolon right there, that's equivalent to like a loop body that has nothing in it. And so it just runs this little loop 10 times, and then when it exits, it goes and runs these two statements. So almost never do you want to put a semicolon right here. There's maybe some rare cases where you might do that. But normally if you do that, then it's probably probably an error. Okay, let's see. So I think, let's see. So, and then also just to show, some people will do things like this. All the values around the semicolons are optional, so I could leave this off. So if I set I to 0 beforehand, then I could leave this off right here, and I could just to show this, I could leave that off. And so this would do the same thing. It would start out and I would be set to 0. It would loop while I is less than 10, and then inside the loop it would add 1 to I. So if you wanted to, you could leave stuff off at the beginning or the end, although that's kind of weird. Most of the time you don't do that. You could even leave off this part in the middle. If you leave this off, then this is equivalent to, or how about I do this as a while loop? So if I left off everything inside here in the middle, that would be the same thing as a loop that says while true, and then just does this forever. So normally you wouldn't see this either, but once in a while I'll see people do it just for kicks, I guess, just to look funny. Okay, so that's the basics of the for loop. Usually it would look the way we did it initially, where you have like I equals something, and you don't have to use I, but I is like a really common variable for looping, just because it's a nice short letter, and we'll use it more when you have an index. Usually it'd be something like this. And then you'd have some code body in here. Yeah?
Yeah, I tried to make one where you can enter the amount of times it runs, but I can't seem to get it to work because it's being declared inside.
Oh yeah, if you want to enter the number of times it runs, then you'd have to do it outside. So it'd be something like this. You'd say like how many numbers to add. And you have to make a variable out here, like num times, and set it equal to next end. And then put it here.
So outside.
Yeah. So it'd be something like this. You know, how many numbers to add? Whatever we type in, then it would loop that many times, and then print it out. So if I just type in 3 here, then I type in 3 numbers, then there's my sum of the 3 things. Any other questions? Okay, so we really briefly went over some of the more, I guess, esoteric ways you might use a for loop, but this is probably the typical way you'd use it like 90% of the time. Let's see, we have two other statements that are sometimes useful, and they are break and continue. And break and continue are statements that you don't have to use because you can do the same thing with if statements. But once in a while, they come in handy. So here I'll just give you an example where you might use them. So you have some while loop, for example. So usually it'd be something like this. And you don't have to put it inside an if, but normally it would be. So let's say we have a while loop, and it's while some condition is true. So let's say it comes in and the condition is true, and we run this first statement. Once in a while, you might want to exit the loop before you have to go back up and check to see if the condition is true. And so what you might do is have like an if statement. If some other condition is true, then add this break. And basically when we hit the break, it makes us exit out of the loop and go straight to this thing. And so it's going to skip this one over here if you hit a break statement. So essentially break is a way, if you want to, you can exit immediately out of the loop without having to go back and check to see if this Boolean condition is still true or not. So if in this case, if this Boolean condition here is false, then it would go ahead and run this statement and just keep on continuing with the regular loop. So one place where this might have been useful is on the previous drill when we were doing the thing with the address. We had a loop that went from like 1 to 9999, and then if you had the matching address, then you printed out the address, and then at that point you could have stopped. There's no need to keep on continuing with the loop when you find the address you're looking for. And so what you could have done in that drill would be had a break statement right after you printed the address, then it would have quit the loop immediately. Otherwise, it kept on continuing with the other numbers even though you really didn't have to. So that's kind of the scenario where you would use the break statement. Here we mention the continue statement as well. If you have a while loop, some Boolean, and some code. If we hit the continue statement, then what this does is it makes it go immediately back to the beginning of the loop. And so it repeats the loop immediately. It doesn't break out. So you're still inside the loop, but all this stuff over here is skipped. So anything that came after the continue statement that's inside the loop gets skipped, and it goes straight back to restart the loop again. So some people don't like the continue because it's a little tricky to understand sometimes, but it's there in case you want to use it. Let's see. All right, so I think I just wanted to mention those. And let me spend the rest of my time going over an example here. So I guess before I do that, are there any questions about break or continue? Yeah.
So, I didn't get the continue really, so won't that loop it again and again too? Because when it reruns the continue, back out one.
Yeah, so it's possible you might get in an infinite loop as long as, so presumably there'd be something here that would make the Boolean eventually become false. And so,
So you could make it break after a certain amount of times.
yeah,
Like that, okay.
yeah. So, and then usually this would be inside an if statement. So there'd be like an if in front of it. If some condition happens, then go back up here. Yeah. I'd say the continue is a little rare. People don't use that one too much. But then the break is more common to exit out of the loop. All right, so this last little example here is, let's say we like to print out all the prime numbers between 3 and 100. So we don't care about, I'm not sure why I started at 3. We could start at 1 or 2, 1 I guess. But anyways, for whatever reason, we're starting at 3, and we want all the prime numbers from 3 to 100. And we have various ways we could do this. And here's kind of the brute force way. So to be a prime number, it means that the only numbers that divide into it are 1 and itself. So one way we could determine if a number is prime is you pick the number. So we pick, like, let's say we start with 100, and you want to know, is it prime? Then what you might do is you might take 99 and see, does 99 evenly divide into 100 with no remainder? If it does, then go on to 98 and 97 and 96 and keep on going all the way down to, in this case, 3. Why did I start at, or 2, sorry, go down to 2. And if none of these evenly divides into 100, then we can conclude that it's a prime number. So so obviously this wouldn't happen for 100. So with 100, when we got down to 50, 50 would evenly divide into 100. And then at that point, we could say, oh, we found a number that divides into 100, so it can't be prime, so let's stop. So our loop to test if a number is prime is, in our brute force way, is start at the number -1, count down until you get to 2, and then if all of those numbers you've tried, none of them evenly divide into 100 in this case, then you can conclude that 100 is prime. So there's just one loop to test for one number, and then we'd like to output all the prime numbers between 3 and 100, and so we could have a loop that sets this value. So you could start with, say, 3, and then go up to 4, and then go up to 5, etc., all the way up to 100, and then test each one of those numbers to see if it's prime or not. So to do that, it means we're going to have these nested loops. And so here's our pseudocode. We'll have a loop where I starts at 3 and goes up to 100. Initially, so if we use 3 here, I equals 3. Initially, we'll assume that it's prime. So I'll have a Boolean variable. So I can make like a Boolean is prime and set it to true. So initially, I'm assuming that 3 is a prime number. And then have a loop that goes from, in this case, 2 to 2, and then see if I divided by j has no remainder. To do that, we can use I mod j, where in this case I is the number we're testing, j is this loop we're counting up to j minus 1. If that equals 0, then it means that there's no remainder, and therefore it couldn't be prime. So if there's no remainder, then it's not a prime number, so we'll set our flag to be not prime. So then this thing is prime. could be set to false. After we loop through all these numbers, if this flag has ever been set to false, then it means that we found a number that evenly divided into the one we're testing. So then we could print out not prime or something, or we could just ignore it. But if this flag was never set to false, then, well, we started out setting it to true, so therefore it must be a prime number because we never found a number that evenly divided it. So then we could print out that it's prime. So that's the idea. So we have a loop inside a loop, which makes a nested loop. So let's see if we can actually write this thing out. Let's move that over there. So in this case, I don't really need a scanner. I'm just going to make it just spit all these numbers out. So first we need a loop that goes from 3 to 100. So anyone care to pick a loop? What would be a good loop for that? Yeah, so a for loop would be good because we're kind of counting from something to something. So I could say for int I equals 3, I less than or equal to 100, I plus plus. So right here I've got a loop that's going to go 3 up to 100. So in this case, I can put a comment here. I is the number we are testing to see if it's prime. So our pseudocode says, well, next we'll have some flag to test to assume that number I is prime. So let's make that a Boolean. So right off the bat, we're going to assume that this is a prime number. And then here in our kind of brute force thing, we're going to have another loop that goes from 2 up to the number -1. So any other ideas on what kind of loop to use? We could use another for loop, would probably be the best choice here. So, so what we're doing next is testing all the numbers from 2 to I-1 to see if one of them evenly divides into I. So here in my pseudocode, I just called it J. So J, in this case, I'm starting at 2 and then going all the way up to I-1 and then adding 1 to J every time. So next we would test if I%J equals 0. So if this happens, that means that J evenly divides into I. So we do I divided by J. If the remainder is 0, then J divides into I, and I have to put parentheses around this whole thing. So if that happened, then I know I don't have a prime number anymore, and I can set is prime to false. And let's see here, and then right here, so after the inner loop is over, if is prime is still true, so if I never set it to false, then it means I didn't find a number that divides into I, so I must be a prime number, so I can print it out. So here I'll just print out that I is prime. Let's see. Okay, so I think that should do it. Any questions so far? So once again, the idea is this outer loop right here loops through all the numbers we're testing. And then this inner loop over here actually determines if the number is prime or not. And then if it is, we print it out. So if I run it, then here it goes and spits out all these numbers. Starting at 3, so it looks like it's correctly printing out all these prime numbers, but it's not a very fast program. If I tried to get to big prime numbers, it's going to take a long time to figure it out. Yeah?
Is this kind of what they do to find like extremely large ones, or obviously using like supercomputers?
No, there's like a different way to do that. That's much faster than this. Yeah, but you could do this, but it would run really slow. And it's a little fancier to do that. We do have a couple ways we could speed this thing up. And so one of them is if we look at this, let's say the number we're testing is 100. So if I is 100, then here we have this loop where j gets set to 2, and then immediately 100 mod 2 is 0. 2 goes into 150 times with the remainder of 0. So immediately we set is prime to false, but then this loops back up and then tries this with j equals 3, then j equals 4 and 5 and so forth. And so we really don't need to do any of those. Once we find one case of a number that evenly divides into I, we could stop. So based on what we've talked about, how would you make it stop once we find a number that evenly divides into it? So yeah, we have a couple ways we could use break. And so one of them would be we could say break right here. And so I'd make it stop right away once it finds a number that divides into it. And if I compile and run it in this short case, you don't see any time difference. But if it was a lot bigger number, you might notice the difference. Another way you could do it, instead of a break, you could have done this. This loop right here is continuing while j is less than I minus 1. And so I could change this. So continue while j is less than I minus 1. And is prime is false. So I could put an and here. So once is prime is set to true, is prime is true. So if is prime gets set to false, then it's going to make this thing become false and then make the loop exit. So that'd be another way you could do it. So you could kind of take your pick over which one you think is easier to read. And then there are like logical ways you can make this thing run faster. So rather than loop all the way up to I minus 1, like when I is 100, there's no use checking 51 all the way up to 99. None of those numbers would ever evenly divide into I. So you could use like I divided by 2 over here instead of I minus 1. So there are other things you could do to make it run a little faster. Okay. So any other questions so far? So let me think if I want to do any other ones here. No. All right, so I guess I'll stop here and let you work on the drill. So what we'll do tomorrow is do one more example with for loops, but use that looping over a picture to do some image processing. And then we'll move on after that to talk about classes and methods. So actually, after covering loops, you can write some pretty complicated programs. And in fact, we've covered like enough concepts that you could actually, in theory, write all kinds of programs. So pretty much any program someone could write, in theory, you could write it with what we've covered so far. Some things would be really messy to do, but theoretically you could do it. So that means that the scope of possible programs for you has expanded dramatically, and it'll keep expanding, I guess. But hopefully it'll get a little bit easier in terms of writing them as we cover more concepts. But just so you know, you're going to start to get more complicated programs because it's possible. Okay, so I'll stop here.